Hello, let's continue the lecture. Now we will start with prefix adder. In the earlier lectures we stopped till carry look ahead adder, and we mentioned that and I think we mentioned that even though carry look ahead adder is faster compared to a ripple carry adder, it is still slow because realizing a carry look ahead adder in the form that was given earlier is a little bit complex, and therefore it is usually limited to small bits, small number of bits, like 4 bits carry look ahead adder, and then each block is cascaded, then again forming a sort of a ripple carry adder. So prefix adder eliminates that problem, and here what is happening is, so a two-stage carry look ahead process is being done. Okay, now let's start with a single block. Consider the first block. Okay, a single block. So what is how? Let's rewrite the equations using small p and small g. And earlier, if you look here, we wrote the equations with capital P, capital G, but the main thing was here we wrote the implementation using A's, B's and C's, right? But here what we are going to do is we are going to completely rewrite the equations for the carry using generate terms and propagate terms, right? And here in fact we are interested in the last one, the last carry, because the individual carries within a block of 4 bits is already taken care of by the first level of carry look ahead adder. Now we are moving forward, and now we are trying to implement a second stage of carry look ahead adder. So we need to predict the carries for each block. So we are interested in the last part. So after you can verify these equations, after doing all these processes, we come to this conclusion that C3 equal to this much. And then again, as usual, whatever we are getting, it is a generate term or a propagate term and a carry term, right? So here it is a carry term. So what is ANDed with the carry term, that will be the propagate term, and then without the carry term, whatever it is there, it will be the generate term. So we can write this as C3 equal to P3 to 0 C in or G3 to 0. That is the propagate block, propagate term for the block, and C in or the input of the block, carry input of the block, or the generate term for the block. Okay, this can be written generally as like this. So this is the carry term for a block. So this particular block we are just reinterpreting or re-representing the whole thing. Again, earlier in our carry generation logic or carry look ahead logic, and the input was A's, B's and C in, right? And the outputs were individual carry terms. But here what we are doing is we are representing the whole thing into smaller bits. So this carry look ahead logic, here we are re-representing using these equations, which is based on the generate and propagate terms. So from this A's and B's, we are finding the generate and propagate terms for each part of the block. Then using that we are finding the carries, right? And the last one. So this much part we are sort of using a shorthand, and we are combining the representation. So this is the representation. This OR and this block is this much, right? And this CLA unit, this is this part, and the final full adder part, it is this one. And even this generation we can again shorten into this much, that is A3 to A0, B3 to B0 is the input. There are 3 stages: the OR, AND stage, the carry look ahead stage, and the full adder stage, and there will be a C in and a C out. So this is one block. This is one block, and now we will be moving forward using this part. Okay, so this is a more general representation of a two-stage carry look ahead adder or a prefix adder. So this is the block that we designed or saw earlier. Like that, we will have 4 blocks, right? So here we are considering a 16-bit prefix adder. So there will be 4 blocks of 4 bits each, and each block is generating a final P3 to P0, G3 to G0. That is a block generation and carry term, propagate term. Like here also P7 to P4, G7 to 4, like this. So each block is generating and giving that generate and propagate terms to the second level CL carry look ahead unit, and using a similar logic, the second level carry look ahead unit will be generating the carry for the next stage. See here, C3 equal to what? P30 C in plus G3 to G0, right? That C3 is going over here. Similarly, C7 can be generated. So what will C7 be? C7 will be what? P7 to P4 and C3, or G7 to G4, right? Just extend the logic that is being used here for the other blocks. So if you look at it here, the sum terms are coming from the individual blocks itself. Only the second level logic is being implemented in the second level carry look ahead adder. Actually, it is quite similar to the single level carry look ahead adder, and it is actually in figuratively and literally it is an extension of the logic. Okay. Earlier, in a simple 4-bit carry look ahead adder, these blocks, there will be a carry generation logic, and these blocks were simple full adders. But here, these small blocks are themselves are what? They are carry look ahead adders, and they have full adders in them, and there will be a carry look ahead logic for providing the predicted carry in advance for each block. It's very similar if you can just compare them one by one. Okay, and this is a generalized representation of the carry generation and carry propagation term for a block, right? So if you look here, we can rewrite this as G3 or P3 and some term, right? Here for these 3 terms we can take P3 as common and write G3 or P3 and some term. That is what is written here. G of I to j equal to G of I to k plus P of I to k and G of k minus 1 to j. Just splitting that. And similarly, this part P of 3 to 0 can be rewritten as P of 3 and some other term. That is what is written here. P of I to j equal to P of I to k and P of k minus 1 to j. Just rewriting this. So if you go to your textbook section 521, you can see some other representations of prefix adders. Some other representation in the sense more implementation level, more hardware level representation. But anyway, this will suffice to understand the problem. Okay. So to once again just review and wind up the topic, carry prefix adder is basically a 2-level carry look ahead adder implementation. Instead of using single full adders, we are using blocks of 4-bit carry look ahead adders and we are providing the predicted carry for each block, and that is being derived using by extending our carry equations using and by interpreting them using generate and propagate terms, and by from them we are getting block propagate and block generate terms, and by using that we can simply generate a carry look ahead adder unit or a second level carry look ahead adder. Thank you.